Hello friends, today let's solve the all paths from source to target problem. Let's first see the statement. Given a directed acyclic graph of n nodes, find all possible paths from node 0 to node n-1 and return them in any order. The graph is given as follows. The nodes are 0, 1, 2, graph.length -1. Graph I is a list of all nodes j for which the edge ij exists. So how is graph represented? Let's see. What does this mean? It means that node 0 is connected to node 1 and node 2. And this means node 1 is connected to node 3. So node 1 connected to node 3. And this means node 2 is connected to node 3. So node 2 is connected to node 3. And this means node 3 doesn't connected with other nodes because it is directed. So there are no other nodes start from the node 3. So because we have to return all the paths, so we can think of use backtracking. Because backtracking is used to exhausted search. We need to search every possible paths. So we need a help function because we can pass more parameters to this function. So basically, this is the idea. We start from the node 0, and we try to go to the next node until we reach the end. If the very last node is the n-1, we find a valid path, so we add them to the result list. If not, we just go back and keep search. So let's write the code. First, we need the result list, new array list. And then we need a temporary list, temporary array list. And we should first add 0 because we start from the 0. And then we call the help function. We pass the result, pass the graph. And the current node we need to record. The current node is 0. And the temporary list. Finally, we just return the result. So in this case, we use the help function. And the first parameter is the result, integer that will be result. And this is a graph, right? And the current node. And this is a temporary node. So as is a recursion, so we need a base case. Base case is the current node is equal to the graph.length -1, because if it's reach the n-1, we have find a valid path, right? So we add the new array list. You should be familiar with this part. We cannot just directly add the temporary list because in Java the function passed by another function is passed the address. So if we just add the temporary list, the value will change. So we should add like the snapshot. So we new array list and pass the current value in the temporary to the result list, and then return. For the recursion part is we try to find the next node. That is graph current node its value, and we add them to the temporary list and do the recursion part result graph. So now the current node becomes to the next and pass the temporary node. So when we backtrack, we will remove the last node. That will be the last node. That will be the temporary size -1. So I think we have finished it. Okay, thank you for watching. See you next time.